Okay, we've got a graph here, so this is going to be a command of evidence quantitative question. Home heating needs met with subsurface thermal pollution, what? For two temperature conditions by percentage of sites, 0% up to 20, more than 25%, percentage of sites. Local heating needs met, current surface temperature maximum, plausible surface. Okay, right away. I don't know what these are. This is a very confusing chart to me. I'm going to do a quick substitution. I'm going to try and plug in something I understand here. Home heating needs met with natural gas. So subsurface thermal pollution, I'm substituting natural gas because I understand that. For two temperature conditions. And I'm going to pretend the temperature conditions are current. So let's call it somewhere cold like New York. And then maximum plausible, well, that's going to be somewhere hot like Florida. So I'm going to think of this as Florida, New York for current, and Florida for maximum. That makes more sense to me. Might not be right, but we'll see. I think that's going to help me read through the conditions. So urbanization, industrialization, the warming climate create thermal pollution in the shallow subsurface soil. Suzanne Benz and colleagues analyzed thousands of sites on 3 continents under one scenario in which surface temperature remains at the current level, and under another in which the surface reaches the maximum plausible temperature. Still don't quite understand what's going on. They then categorized each site according to the percentage of local home heating needs that could be met using the excess subsurface heat. The team concluded that as surface temperature approaches the maximum plausible level, the percentage of sites with thermal pollution could feasibly contribute to home heating needs will increase. Okay, so this is a best support, and the conclusion we have to support is that if surface temperature approaches maximum plausible level, so in my case in Florida, the percentage of sites where natural gas could contribute to home heating needs will increase. Well, okay, let's go back up to the graph. So in current temperatures in New York, natural gas contributes, for most of the homes, natural gas can't contribute to home heating needs. And in Florida, there are very few homes where no natural gas can contribute, where there's no possibility. In fact, in Florida, the vast majority of homes, natural gas can contribute more than 25% of home heating needs, so a large portion of home heating needs. So let's take a look at the answers and see what we get. A, under both temperature conditions, that is in New York and Florida as my translation, less than 10% of sites were in the up to 25% group. Let's just quick check the graph. Is it accurate? Yes, both were less than 10%. That's true. But at the maximum plausible surface temperature, almost 80% of sites could have all their local heating needs met by natural gas. So in Florida, almost 80% of sites could have all their not all their local heating needs, 25% or more. That's not the same as all their heating needs. That's a wrong condition. That's going to be the wrong answer. B, at current surface temperatures in New York, more than 80% of sites have no need for supplemental local home heating. Yeah, that was true, right? 0%, 80% plus homes in New York had any need or ability to use natural gas. So, all right, that's true. Good. That's accurate to the text, to the graph. But at the maximum plausible in Florida, more than 70% of sites exhibit significantly greater home heating needs. Well, what does that mean? 70% of sites have significantly greater, the bar is 70% or greater, can have their heating needs more than 25% of their heating needs met by, and this is my substitution, natural gas. Significantly greater home heating is not about the home heating needs. It's the fact that they can use it to meet some percentage of their home heating needs. It's not that they have greater home heating needs. That's not what the chart says. Let's just double check that. Local heating needs met. Significantly greater. No, I think that's the wrong actual condition. So I don't think it's B. C, at current surface temperatures in New York, more than 80% of sites can meet at most 25% of local home heating needs with subthermal pollution with natural gas. But at the maximum in Florida, more than 80% of sites can meet greater than 25% of local home heating needs. Yeah, see how this is very different language than this over here, which tells me that that is wrong. This looks to be true. More than 80% of sites can meet greater than 25% of local home heating needs in Florida. Was that right? Well, actually, it's just under 80%. So I think that's not right. I think that's actually incorrect. More than 80% of sites can meet greater than 20. No, it was like 78%, not more than 80%. Here's an odd part too. At current surface temperatures, more than 80% of sites can meet at most 20. So at most 25%. I'm gonna assume that means up to 25%. That at most 25% and up to 25% are the same category, which means this is definitely not accurate to the chart because it's not 80%, it's like 10% or less, okay? But here's the thing, does that include 0%? If it includes 0%, because technically at most is less than or equal to 25%, which in theory includes 0%. So I'd add the 80 to some single digit number and I'd get more than 80. And that would be true, but why would they break out 0% as a separate category in that case? So this is, maybe a flaw in the problem here. I think it's written by somebody who's trying to connect the wordage at most 25 up to 25, which is good, but they should really label it between 0 and 25. Anyway, so I'm going to assume that that's a separate category, and this is definitely not accurate to the graph. So D. Hopefully that's going to be our answer. At current surface temperatures in New York, more than 80% of the sites cannot use natural gas to meet any portion of home heating needs. Yeah, that was correct, right? In New York, 80% of the homes cannot use any natural gas. There's no potential, 0% potential. So that's true. That's accurate. And that's kind of relevant to what our conclusion was for the teams, right? From the group. The next part is, but at maximum plausible in Florida, that percentage drops below. So that percentage is the percentage that can have no extra home heating needs met, just to be clear. So that would be the percentage that's 0 for Florida, and that's less than 20%. It's just over 10%. That's true too. That's accurate. And this is the idea. So the idea here is that, in my translation, at New York, the vast majority of homes can't get any of their heating needs met by natural gas. But in Florida, more than 25% of vast majority of homes can have more than 25% of their heating needs net. And there's only a very small portion that can't have any benefit of their home heating needs met. That was the conclusion from the graph. That was the conclusion from the study. And that seems to match D. I don't know if my translation to what I think is simpler helps in this, because when I read it, the graph was tricky. I read it. I didn't understand that. If anything, it made it worse. But plugging in the natural gas, New York, Florida instead helped me actually reason through the conditions. And I think I was able to reason through the conditions. In fact, I argue that they have possibly a flaw in the way this graph is set up in C. In fact, it's just perhaps we could just say it's poorly labeled, that at most or up to 25% bucket. And I think D is the answer.